So in college, I was able to get my computer engineering degree and was able to eventually work for the Baylor College of Medicine, working here for about 3.5 years as a scientific programmer. And now here at UT, I'm a data manager in the labs. And so my responsibility, when people ask me, what do you do? I don't want to go into detail so much because some people just, I'm not interested. But if I say that, I program robots, they say, oh, you do? Oh, okay. So I do program the robots and also do the database, managing the data and stuff like that for the labs, and also manage servers. I do IT stuff. So jack of all trades kind of thing.
Kite, more mature than he is, so by the time I finished school, I owned $6,000 for my education. So I was blessed. With scholarships and grants and stuff, I only own $6,000 compared to today.
Yeah.
You all, $6,000 may pay for a
quarter of a semester.
that much, a quarter of a semester. It's 1/4 of a semester. So I was blessed to be able to go back to school back early, and I did my own footwork. Brought my own proposals to get to school, did all my own grant work. So young people that's getting ready to go off to school, part of that responsibility is yours and not all your mother or your father. You have to do your part so you'll know exactly what you're doing as well. I'm trying to encourage you all to be responsible. I am going to set you all up in 2 sets of pipetters. First we're going to practice.
Yes.
It's important to practice to know how to do this. Because accuracy in this work is very important. Because if you're not accurate, you don't follow instructions, you can get bad results, and you just lost thousands of DNA in some of our projects. We're really doing all our studies, and that comes from the mother, just to see if the correlation as to why a particular genetic factor may came through the mother. So we do look at mitochondrial DNA in all our big studies. And in our big studies, right now, a lot more studies are looking at mitochondrial DNA to see a source of some genetic defect or genetic areas. Because some genetic defects are based on gender. Some stuff comes through the X chromosome, some comes through the Y chromosome, some comes, only men get it, some only female get it. And they still try to figure out why is that. The mitochondria is stored in chemical bases. Do you know what those 4 chemical bases are? Not you already answered all the questions. You're going to get an A for today.
Okay. Students.
Okay, you can give one of them.
Adenosine.
Adenosine, which normally represents an A in a lot of our genetics. Okay, adenosine, what's the other one? Okay. Okay, what else? Don't give me all of them.
I think glycine,
Yeah.
And
and cytosine. Okay, it's normally AGCT. So the DNA consists of about 3 billion base pairs, and 99% of those are bases. Of course, you have the bases, and then you have the sugar background to make up the DNA. So if everybody have I didn't print out a lot of these, and just a little small schematic of how the DNA looks. And this is a little background about the DNA, which y'all already had from when we had our class on DNA. I think it was last month. So last month, who are isolated strawberry DNA? Okay, was that fun?
Yes.
Yeah, it was a lot of fun. These are
strawberry.
automatic, so there'll be 8 microliters, 10 microliters, 20 microliters, 40 microliters. The big pipette holds up to 1,000 microliters or 1 ml. So everything's in matrix. So the way you pipette, there's a big old line on the thing on the board on high pipetting skills. So you actually pipette, and the markings are on here where you need to pipette. Somebody's going to be pipetting for me shortly. And on here they have graduated, but I don't look at those that much. I have this set for 30 microliters. So when you pipette, you mash the plunger down. Because somebody's going to be doing this when they do their DNA extraction. That's what I'm trying to teach you all something. Mash your plunger down, put it inside the liquid, and let the plunger up. That's a clear one. Plunge it down inside the liquid, plunge it up. Can y'all see it? Yes. So the more you do this, you'll know like, man, that's 30 microliters. So since she have a smaller volume than her, so she's have about 20 microliters in her tip.
You go.
Okay, you go next. Oh, I forgot to ask you how much you had. How much you pipetted? 15. Okay. Oh, now y'all can get y'all pipetting now. How much you pipetting?
13.
Okay, sure.
There's a bubble.
In this kit, each one of the kids have instructions, so I need the ones who's going to be doing the extraction to read this, to look at the instructions and follow the instructions. Following the instructions is very important to have good quality results.
And then the first try.
What are they mixing it with?
Well, they put the cap, the liquid's inside this cap, and when you pour it down, the liquid mixes with the saliva. So then it makes
Cap on it.
it.
They gotta produce this cap on it and the liquid's in there.
If you look at it, that's what everybody feels. Read your instructions. While you're waiting, read your instructions.
Yeah, turn it upside
Mix
down.
it up.
Everybody.
These are gonna be this way.
Oh, Set it at the same time so we should
Everybody finished?
Who's counting?
Okay, after we extract our DNA and get our sample set that we're going to genotype, you take our DNA and robotically transfer it into, we call this a genotyping plate. It has 384 wells. And so in this genotyping plate, we can put controls, we can put samples that has no DNA, samples that has DNA that we know about, characteristics of as a control, and we can put unknown DNA into this plate. And what we normally do with the robot, which I will do a small demonstration for you. We add all our reagents together, and in the reagents that we add together is the sequence, the primers. What is a primer? It's something that tells your DNA to start reproducing itself. So we end up putting it up and we put it in the reservoir. And we actually pipette that in like you all was pipetting before. We literally pipette that into the reservoir. We only do one cocktail at a time. We pipette it into the reservoir. Actually, you can pick up 96 pipette tips at a time, transfer 96 samples at one time. And this particular robot has a light curve. If you hit this, it'll go off and stop thinking like it is. To keep you from hurting yourself, so don't step back. It's gonna pick up all of those tips, like you was doing stuff manually. We don't do stuff manually in the lab itself, but it's just a little work. Everything else is done in the robot. And it's gonna go into that reservoir and pick up however many microliters I tell it to pick up. It told it to pick up 5. So it's gonna go there and stick it into that 3-4 little plate. It's gonna do that 4 times. Since we have put stuff in the back end where you can't see it, but you'll look at it when we finish working. There's a light curve right there. If you do like this, it'll stop. So people will go stick their head in there. This is the aluminum genotyping lab. And of course, again, we have robots to do all our work. And this particular genotyping can do 2.5 million genotypes at one time. So on these little bitty squares, we have our DNA. The little, you can probably can't even see it in the microscope to see them. And we put our DNA on a little bitty square, and you can genotype up to 2.5 million genotypes on that one little bitty spot. And that's our aluminum genotyping platform. So we go from 3, we can go from doing 96, which is what we did in the old days. In the old days, we could only do 96 at a time. And then when technology changed, we changed with the technology. We went from 96 to 384. When technology changed again, we went from 3 and 4 to 11. This is a tray that holds the chips to go into our machine that beats it. So our robots actually add, these robots add the DNA to the moving square. And these are, the reason why they had the color on this is because we have to stand it with a die so the machine can read it. So we stand to a die and it goes into them. So we just pile all our experiments up on here, cover it with the cover, and the machine will take it and put the robot will come around, pick this lid up, put it right here, take this, and put it in the machine. I should have had that. That was part of this job.
Excuse me. You know the bottom of these?
It just holds the carrier.
No, I know, but what are those things?
I don't know. You're gonna have to become an engineer and tell me what they are.
They're straight.
Yeah, the engineer tells me they are. That's the engineer tells me what those are. So you have to become an engineer so you can tell me what
On
it
the
is.
bottom of this,
Uh-huh.
I'll show you what it is.
Yeah,
What's that?
yeah. An engineer produced that. I don't know. You gonna become an engineer?
No.
What you gonna? Okay, so okay, Mr. Engineer.